Hey guys, back again with another tutorial. In this video, I'm going to focus on shooting and editing a time-lapse sequence of the moon, and particularly Moonrise. Out of all the lapses that I've shot, my Moonrise time-lapse have easily received the most attention. But I'm also going to include some failed attempts so you can avoid making some of the same mistakes. And up until now, I've yet to find just a comprehensive guide on moon-lapse from start to finish. So let's go ahead and get started. Alright, so first off, we'll need moon data. Time and date here is a great resource. There's plenty of good stuff out there. Moonrise is what you need to know, and then percentage full. So you can kind of think of a full moon as a 3-day opportunity to get out there and shoot. Full moon's going to be right around sunset, but these other times is either going to be before sunset or after sunset, so your exposure is going to be, variable upon that. And then to bring that into kind of an animation form, check out MoonCalc here. You can animate it on and see exactly, where to expect that path to rise. And same with TPE, the photographer's ephemeris here. And you can zoom in and see, where's that really going to rise over. And this is a shot that I've taken a few different times from this location. So check out these moon data. You'll need to know everything you can about where this is going to rise to get your best results. Alright, so there's going to be a few factors that are going to be different for every observer's location. And also, depending what time of the year, the path of the moonrise is going to vary. But in the northern hemisphere, you'll see it, for the most part, ascend from the left off the horizon to the right up as it continues in the sky. You can see it right here. This is about 36 degrees north latitude where I shot most of these. So, if you're in the southern hemisphere, you're going to see it go right to left. And if you're at the equator, you're going to see it more rise at a straight line. It's best to just do a test first, find an elevated area or elevated enough so that you can clearly see the horizon. And, there's apps that you can get for your phone to help plot that location while you're out there. But tracking the moon before you can see it is definitely not the easiest thing to do, even when you know the time and the area that it's going to come up on. And so depending what your atmospheric conditions are, it may affect the initial sight of the moon right off the horizon, whether it's high cirrus clouds like I had with this one, or just a slight haze that you can see in the air. There was some smoke and whatnot in this one. So when choosing your foreground object, it helps to be familiar with the location. And keep in mind the moon never changes in size. You'll need to create distance between you and your foreground object for the moon to appear larger in comparison with your foreground. So you can see with this one I was 3 miles out from the target, and with this one I was 5 miles actually out. So the further the better, but you can't always get 3 miles from your intended target, so work with what you can. And then that also gets into lenses and whatnot. So I'll jump into the shooting aspect now. So with this tutorial, I'll be focusing on camera lens versus the telescope or mirror to shoot. And of course you get much closer images with the telescope and usually more detailed, but too tightly framed for a full time-lapse sequence. A good lens for shooting, would reach into the hundreds of millimeters, and you can find extenders that can be attached to the same lens to increase your focal length, and usually at a more affordable price. And with those higher focal lengths, you're going to get a lot better lens compression, flattening that image and making the moon a lot larger. Not everyone has the extreme telephoto lens, so I'll focus kind of more on a focal range that most people would probably have in their kit. My setup here currently is a MD and MC to E-mount adapter the 2x multiplier, and then the 70 to 150 millimeter lens. And since this is a crop sensor, 1.6 crop sensor, that really brings the lens without the adapter to 120 millimeters to about 240 millimeters. So let's get into focal lengths real quick and maybe understand this a little bit better. Here are 4 different focal lengths from that same lens I just showed you. The 2 on the left is just the lens, and the 2 on the right are the lens with the extender. And I find that, with my past lapses, the extender really wasn't needed. As you can see, 240 is fine enough. The higher millimeter, the larger the moon will seem, but faster the moon will travel through your frame. If you plan on using a telescope or the telephoto lens with the higher focal length, I would suggest probably creating a video file instead of an image sequence. The disadvantage there would be the amount of editing control that you'll have after you're done shooting it. It's important to shoot wide enough to get as much as the moon's path in frame, and especially when you're trying to predict the exact placement on the horizon, because it may be off a little bit and you want it wide enough to pick it up. Keep in mind you can always crop later, and these raw files are pretty big to begin with, so you can see when I pull in a sequence into here, and automatically it's bigger than the 1080 frame. So right here it's around 32% that I need to bring it back to get the whole thing in frame. And even then I have room above and below, so I ended up cropping it in, and ended up with something like this for the framing, which is about 50%, so the detail was still really good. Your best results will come from raw images, and when I say raw, it's really a combination of file types. It's not just one image file type, and what it is a digital negative, essentially a representation of your image. And when you take it into things like Lightroom, you can expose it and really make it what it would be, your final print. And here's an example of a raw photo before and after. This is one that I shot at the fair, pretty dark exposure, but ended up bringing it up a lot, and you can see the colors and everything. It just dramatically improves your overall look of your images, even if you make mistakes when shooting, or certain times you're looking at the live view and you're just not seeing the right thing that you'd see on a computer. The biggest difficulty when shooting these is controlling your exposure as the moon rises, because a full moon occurs within 30 minutes at most of sunset, making it difficult enough to control your exposure a day to night. But the moon's going to rise, and it gains exponential brightness as it rises, so you're kind of there's 2 things happening there with your exposure, and at its peak magnitude, as you can see here, it's half as bright as the sun would be. So you got to keep that in mind when you're shooting. You'll need to become familiar with a few camera settings and time-lapse methods, but one last thing I do want to mention is, get a strong tripod out there so that you can skip a step in stabilization. High millimeters, any shaking of the lens is going to be literally magnified, so just be aware of that. So camera settings real quick. As I've said before, RAW is a must if you want the most control over your images. Keep your ISO low. That's your camera's sensitivity to the light, and you're going to be getting a lot of light from the moon as it gains elevation in the sky. Your aperture, I'd probably keep around f8, maybe 5.6 at the lowest, up to 16 at the highest. With that tighter aperture, it's going to be easier to focus opposed to a wide open aperture. So shutter speed, this can vary with pleasing results, and I'll get into that in a second. Your interval here is important. It also depends on your framing, but I'd say 1 to 2, maybe 3 seconds You know, the moon is a fast moving object, so you'll need to keep a short interval in order to achieve the smoothest results. And intervalometer options, you know, depending on what you have and what you're using for your intervalometer. My camera has a kind of a sunset setting that adjusts my shutter speed over time. I've used that once. I've done custom settings, but I have an internal intervalometer, so check out your options on that. But I'm going to get into time-lapse real quick. I'm going to slowly walk up this ladder of methods, just kind of from basic to a little more advanced. So constant settings, you know, you choose one set of shutter speed, aperture, ISO, and you just leave it throughout the entire thing and deal with the post-processing later. These may be shorter lapses because the moon may get really bright over time. The other options, internal and external intervalometer settings. And this is what I mentioned kind of earlier. You can get in there and see if it has like a sunset setting or something that would adjust, takes your shutter speed and, you know, slowly makes it longer as it gets darker. And this is similar to like an aperture priority mode that you can find on your cameras. And lastly, you know, the variable and adjustable, which is kind of like the holy grail technique. It's going to be much easier to control these jumps in exposure with your shutter speed rather than adjusting your aperture. And with the upcoming lunar eclipse, this is the technique you'll want to shoot for. Okay, so I'll go ahead and jump into the editing and show you what's happening behind the scenes. Whichever method you end up choosing, you'll still need software to process the images. And Photoshop's one of the most common image editing softwares out there, and it carries a plugin called Camera Raw that handles all the raw file types and allows for many of the same editing options as Lightroom's development panel. My personal workflow is to open Bridge, move files into their location so that it's just the sequence in that folder. If I decide to open it up here in Bridge, I'll go ahead and show you. It'll automatically go through Photoshop and open Camera Raw here. And you can see that this sequence was a consistent, right here, my shutter speed 1/3. There's 425 images here, and by the end of the sequence, you know, you don't see anything. So if I were to edit this photo, let's just do a quick edit. Let's say select all, synchronize. So if I were to choose the last image, you know, that looks decent. But when I go back up to the top, I'm blown out on my first image. So what you can do here is go somewhere in the middle, adjust your exposure to that location, and then synchronize it from there. These may be shorter sequences just because your exposure is going to change. So this is kind of a beginner's option. You can just choose one edit and apply that to each image of the sequence. So any changes made to these raw files are saved in a separate file structure called the XMP file, and this is what it looks like. It has all your information about, you know, there's clarity, there's noise reduction. It saves this into a data file and then adds this to your negative. So when I separate these XMP folders and I just get my raw images back, I'm able to edit them again. There's other ways that you can control your files out there. Here's that same sequence, constant settings, as I was saying. The shutter speed, ISO, and interval will stay the same throughout the entire thing. And you can see that this blue line right here is the exposure over time. And you can see it starts bright and then slowly gets darker over time. And you can see this other yellow line is the corrections that I made in exposure as it continues. So I'll turn my visual previews. This is all the XMP data loaded, and these are all the changes that it recognized that I made. And these blue dots are my keyframes. So I chose, you know, image 0, it chose image 81, I think it was. And I said I want this photo to look this way, I want this photo to look this way. And so by the time we go back and look at this sequence, the software has created the adjustments between each keyframe as we go. And so this is an option for a little bit more advanced techniques, but you will also get the most control here. So the same sequence, constant settings, and you can see the results here. So this software will give you the most control over any sequence, and hands down is the best software for time lapses of really any kind. So from here out, I'm going to use LR Time-Lapse to basically explain these other sequences due to its graphical representations. So this lapse was shot using the sunset setting on the intervalometer application found on my camera, and you can see that these exposure line is kind of a wavy. It's not going straight down over time. This is because, as you see right here, my shutter speed was slowly being adjusted as it got darker. It starts with 1/5 and then ends with 2 seconds. So when we look at the raw files here, or I guess unedited files, we can see kind of the results. And by the time we get here, extremely blown out, 2 seconds. So when I turn on my visual previews here, this shows basically the edits that I made, and you can see that some of that detail got brought back in the moon, and the exposure line that I had is now a little more consistent, a little more steady than the waviness. And you can see I only chose 4 keyframes for this one. So this is an option, you let your camera kind of do the work, and it will adjust your exposure pretty well, but you'll still notice some kind of issues, and by the time you make it to 2 seconds, that's just going to be too blown out. The original export of this sequence was done in Camera Raw by editing just one image and applying that XMP data to the whole sequence. It worked well due to the exposure line being pretty even. I did go back and create a LR time-lapse version, and that's what you see here. Let's take a look at this lapse. This one was shot with the adjustable method, and you can see this exposure line right here. Since this is the most advanced method, it's hard to cover briefly, but I'll give you a quick overview on how it works. I plan on doing a tutorial next that just specifically is on this method. I call this adjustable method because you're adjusting your exposure settings manually during the lapse. It's important that you keep that same interval as close as possible. You can see right here, I took 13 seconds for me to change the shutter speed time, and right there, not only do you see a jump in the smoothness, but you also see the camera shaking from when I had to press the button back down. So it's important to keep that interval the same rate. Interrupting your interval will result in that jumpy playback. And so your shutter speed is what you're wanting to adjust if you choose this method. You can see here in LR Time-Lapse that when there's a change to the shutter speed, it gives me these little markings, and it prompts me to use the Holy Grail wizard in order to adjust my exposure. Although I've already created my keyframes here, so I'll go ahead and click on the visual previews. And you can see that those jumps in exposure are corrected. If it wasn't for the jumpiness of the frame, it would look a lot better. But overall, the exposure jump right there is unnoticeable. And this is how you're going to get the best control of the moon as it rises. And so as we get about, at least 5 degrees in the sky here, we're at 1/8 of a shutter. So this was a pretty clear sky. There's a little bit of the high cirrus clouds, but this is how you're going to get most control over your image, is if you adjust your shutter speed as you go. So I appreciate everybody for checking out the tutorial. I'm going to have another one coming up soon. Any questions, concerns, send them my way, and I look forward to hearing from you.